So good afternoon everybody, this is next video on elasticity. So we are discussing a question. So we need to find the breaking strength. So we know that breaking strength is breaking stress into area. Breaking stress is given to be this and area is given to be this. So we just multiply, then we get this as the breaking strength. That signifies that if a force of 3.14 million means 10 is to power 6 Newton is applied on this longitudinally, then it will break. So now let's start a question. There is a road and to the road is attached a given mass m. So we need to find the stress. So stress is force by area. Force here will be mg. So after calculations it comes out to be 3.3 into 10 is to power 10. Now the breaking stress is 10 is to power 12, which is very greater than the stress here, so it will not break. Then we need to find the breaking strength. We know that breaking strength is breaking stress into area. Breaking stress is as area is pi r square, so we have pi r square as. Next is we are being asked the minimum diameter of a wire. So for safely lifting of mass, stress should be very less than breaking stress. So we can say that mg by a should be less than s, or mg by a should be less than a, or area should be greater than this. So after these calculations, minimum radius comes out to be root mg upon pi, or minimum diameter is double of this. So in this way you can solve this question. Now let's start with another question, which is about mass pulley system. So a system of mass pulley is shown. We need to find acceleration of the blocks, then tension in the spring, then tension in another string, net force on the system, stress in the wires, strain, percentage strain, energy density, and elastic potential energy. So question is like this. It's a very simple question. Acceleration comes out to be 20g over here, 10g over here. So it's 10 by 3, the first one. Next we apply Newton's second law on this. So we have net force is equal to ma. From here we can calculate tension as this much. Then we need to find tension, this T2. So if we draw the free body diagram, here it is T2, here it is T1, here it is T1. So this has got net force 0, so T2 is equal to twice of T1. So we can calculate this. Then we need to find the net force on the system. So if we analyze the entire system, you can see that these are equal and opposite pairs, so they will get cancelled out, and hence the net force will be just 100 and 200, which will be 300 Newton over here. Next is we need to find the stress, so which is force by area. So you can find the stress using the simple formula. Then we need to find the strain. So using the concept of Young's modulus, we can find the strain as this. Percentage strain just multiplied by 100. Then we have energy density, which is half stress strain. It comes out to be this. Then we have potential energy stored, so it is energy density into volume. So it comes out to be this much. Let's begin with the next question. So this is a question based on wedge. We are being given a wedge, and it is stationary. So we need to find, the first question is net force on the wedge. Obviously net force is 0 because it's stationary. So its velocity is continuously 0. That means acceleration is 0. Then we need to find area of the face ABEF, then ABCD, then longitudinal stress on the faces, then ratio of the stress. So let's begin with the ABEF. So as per face AB, EF is concerned, we can say that area is length into breadth. Then for ABCD, now this is ABCD. So this thing is certainly B, but this thing will be L by sine theta as calculated over here. So area will be BL upon sine theta. Next is longitudinal stress on face ABCD. So for longitudinal stress, we have to take component of force perpendicular to the area. So you can see over here, the force perpendicular to the area here is F sine theta. So stress is force by area. So after calculations, it comes out to be this. Then tangential stress, for that you need to take the tangential force, which is F cos theta. So using this we can find the tangential force. Then the ratio, you can simply take the ratio and it will come out to be 10. Then let's start with another question. It is based on the stress strain curve. So here are given two graphs for material A and B. We need to find Young modulus of A, then Young modulus of B, then the ratio, then theta for which they are equal, YA greater than YB less than YB. So firstly, for graph A, we can see the angle from the strain axis is theta. So Young's modulus is going to be 10 theta. However, for the second substance B, angle from stress axis is theta. So we have to take from strain axis. So that will be 90 minus theta, which will be equal to cot theta. If we calculate the ratio comes out to be 10 square theta under condition under which they are equal. So if you equate them, put 10 square theta 1, so theta will be 45. Conditions for which YA greater than YB. So YA is greater than YB. The ratio is 10 square theta. So it should be greater than 1, which implies 10 theta greater than 1, which implies that theta should be greater than 45. And for the next question, obviously it should be less than 45. Let's begin with the next question. The next question is about dimension formula of stress. So we know that dimension formula of stress is m1l minus 1 t minus 2. Then is on SI unit, it is Newton per meter square or kg per meter second square. Then about CGS unit, it is Dan per centimeter square. Ratio, if we calculate, it comes out to be 10. So let's start with another concept of, it is called the torsional pendulum. So torsional pendulum is something like you have distorted something and it applies a certain force. Then there is a torque on this. Suppose there is a rod and you just keep this point fixed and just rotate it. So you will feel that due to change in shape, it will try to create a restoring torque. That restoring torque is inversely proportional to the torsional angle. So the graph will be a straight line and tan alpha will be C. If we are being given two constants, then if alpha 2 is greater than alpha 1, that implies tan alpha 2 will be greater than tan alpha 1. That implies C2 will be greater than C1. So there is a very interesting question on that. It's about the time period of rotation of torsional pendulum. So torque is equal to minus C theta. It can be written as I alpha. So alpha is gonna be this. So omega square is this. Omega is this. Time period is 2 pi by omega. So we have the time period as 2 pi root I by C, where I is the moment of inertia. C is called the torsional constant. If you draw graph between T and I, that will be a parabola turning toward I axis, and for T and C, that will be having a shape like rectangular hyperbola. Energy stored in this is equal to half C phi square. Graphs of energy and phi will be parabola. Energy versus C will be a straight line, and phi square will also be a straight line. Let's move to the next question. It's a numerical based on bulk modulus. Bulk modulus for a certain